So the next step up in things that we're going to work on sketching the curves of are rational functions. And again, just like the polynomials we did previously, you've already got a pretty decent grasp of these. So this is really an opportunity for us to practice these new skills, this increasing and decreasing, this finding extrema. And again, we're building our way up. In the next lecture, we're going to talk about different kinds of exponential and logarithmic functions, and some trigonometric functions that we really don't have the tools to handle without our new calculus additions. So this is our process again. This is the same process I outlined at the beginning of the previous lecture. One thing you might kind of slip in here, I added as a step 1A, if you like, simplify. You've seen this before when you're working with rational expressions. It's almost always beneficial to simplify it first if you can. That's especially going to be true when it comes to graphing and we have to take the derivative of these things. It's almost always going to involve the quotient rule, and we need to make that thing as simple as we can. All right, so let's start with this thing, 1 over x squared minus 9. So I want to start with the domain. Right, start with simplifying. We can't simplify this any further, right? Because the numerator can't be factored any further. So the domain, where is the denominator equal to 0? Well, the denominator equals 0 at x equals plus or minus 3. So our domain is going to have to exclude those two numbers. We're now thinking about asymptotes. Remember, the vertical asymptotes occur where the denominator equals 0, and those are the values we just found to exclude when we were talking about what's not in the domain. So there will be a vertical asymptote at x equals 3, and another one at x equals negative 3. So let me add those to the graph. I'm going to go to negative 3. Then over here I'll do positive 3. There we go. And how about horizontal ones? Well, you talk about this in your college algebra class. We talked about it here when we were talking about limits. The degree of the numerator is 2. The degree of the numerator is 0. The denominator is 2. The denominator is bigger, so this has an asymptote at y equals 0. So let me add that to my graph here. Okay. Now what? Now we could jump to the calculus, but one thing I would point out, this is made up of polynomials, numerator and denominator are both polynomials, and they both involve only even exponents. Right, so one thing that stands out to me, this graph is going to be symmetric with respect to the y-axis. All right, so now let's get on with the calculus bit. Let's find the derivative of this thing. And I am not going to use the quotient rule here. Right, because that numerator has no variables in it, it's quicker, I think, to rewrite it this way. I'm going to say, think of f of x as x squared minus 9 to the negative first, and turn this into a chain rule situation, which to me is easier to use. All right, so that means f prime of x is negative x squared minus 9 to the negative second times the derivative of x squared minus 9. All right, let's see, that derivative, that's 2x. So this is minus 2x over x squared minus 9 squared. Okay, so now I need to take the numerator, the denominator, set them equal to 0, figure out what's happening there. So if I set the numerator equal to 0, negative 2x equals 0, I get x equals 0. And if I set the denominator equal to 0, I get x equals plus or minus 3. Okay, I know that there are no extrema at plus or minus 3, right? Because the function isn't defined there. The function can't have extrema, maxima, or minima at a place where it isn't defined. All right, but I do want to keep them on my list, right? Because I want to talk about increasing versus decreasing as well, and the derivative is potentially going to change sign at those points, right? So I am going to put them on my little number line down here. So let's do a number line. I'm going to do -3, 0, and +3. Let's see, let's test -4, -1, 1, and 4. All right, so let's see, if I put negative, okay, first, remember, what I really care about is the sign, okay? And the first thing that stands out to me looking at the derivative, that denominator is always positive, right? Whatever number you put in there for x, when you, in the end, when you square that result, you're going to get a positive number. So the numerator is really what's driving this. When I put -4 in, I get +8 over that positive denominator, and that's positive. When I put -1 in, I get +1 over that positive denominator, which is positive. Put 1 in, you get a negative number divided by a positive number. That's negative. And when I put 4 in, again, negative divided by positive is negative. Okay, so what's going on at 0? At 0, what's happening here? The graph is increasing on the right, on the left side, decreasing on the left side. So 0 is a relative maximum. Okay, -3 and 3, those aren't extrema, even if the sign had changed, which it didn't. Right, so now I should know enough to do my graph. The function has to be increasing to the left of -3, right? That's this positive derivative here. So to the left of -3, that tells me I have to start above the asymptote and go up towards the vertical asymptote. I couldn't have gone below it, right? Because if I had drawn the graph below it, it would have to have been decreasing. Okay, so then what happens here? Well, first, real quick, what's f of 0? F of 0 is -1/9. Almost makes it up to the axis. All right, so what's it doing? To the left of 0, it's increasing. When it gets to 0, it's -1/9, almost up to the origin. Then it's going to turn around and drop back down. Then on the right side of 3, it's decreasing. Excellent. That tells me it has to start up here at the vertical asymptote, drop down, and taper off to the other asymptote. There you go. So you see, previously, using the techniques of college algebra, you would have had to pick points, right? You would have had to pick points to the left of -3, to the right of +3, substitute those into the original equation to find out if you were above or below the x-axis. Now, I get that for free from the work I did trying to find the extrema, right? Increasing versus decreasing answers that question for me. Okay, take a look at this, guys. See what you think. No getting around the quotient rule at this point because there's a variable up there in the numerator. So pause this, take a minute, right? Work this one out, see what you come up with. Okay, the first thing that stands out here, I want to just throw this out to you. If you didn't see this, this is fine. I like to point these things out because I want you to first to see what my thinking is, and I want you to see the kinds of things that I'm thinking about as I approach a question like this. So you can kind of add them into your own thinking. The first thing I notice here is that the numerator of this thing is always greater, excuse me, I got it backwards. The numerator is always less than the denominator, right? And because the numerator is always less than the denominator, f of x has to be less than or equal to 1, And on the other side, it has to be greater than or equal to -1. So it's going to be stuck in this very narrow band here. Right? So now with that said, let's do our routine here. What is the domain of this function? Well, the denominator is never equal to 0. So the domain is all real numbers. What are the intercepts? Let's do the y-intercept. Y equals f of 0 is 0 over 0 squared plus 1, which is 0. It's the origin. Let me put that on my graph. Right, there's the origin. All right, how about x-intercepts? Well, if I set f of x equal to 0, that only happens when the numerator equals 0. And yeah, we found that one already. We already knew that. All right, so we only have one intercept, and it's at the origin. Okay, now what? Asymptotes. Well, it doesn't have any vertical ones because the denominator was never equal to 0. Horizontal ones, on the other hand, let's see, the degree of the numerator is 1. The degree of the denominator is 2. The denominator is greater, so it has a horizontal asymptote at y equals 0. And you notice, hopefully you saw this behavior in your college algebra class. The asymptote, the graph is going to cross the asymptote at the origin, and that's okay with horizontal asymptotes. The horizontal asymptote is telling us the end behavior. What happens when x gets really large? What happens when x gets really small? What x is doing when x is in the middle, all bets are off. And yeah, it's absolutely okay for it to cross the asymptote there in the middle. Okay, now let's do the calculus bit. Let's get the derivative. F prime of x equals the bottom, x squared plus 1, times the derivative of the top. That's 1. Minus the top times the derivative of the bottom. That's 2x. Over x squared plus 1 squared. All right, so what does this simplify to? This is x squared plus 1 minus 2x squared all over x squared plus 1 squared. So that numerator is minus x squared plus 1 over x squared plus 1 squared. All right, where does this equal 0? Right, this equals 0 whenever the numerator equals 0, right? Multiply through by that denominator, clear it out, and we're left with minus x squared plus 1 equals 0. So that's x squared equals 1. X is plus or minus 1. All right, let's do our thing, right? Do our number line here. See what's happening on each side. I'm going to test -2, 0, and +2. And where's my derivative? It's easy to lose it sometimes in all that we're doing. This is the derivative. Okay, and I'm going to use kind of the same little shortcut I did last time. The denominator of this thing is always positive, right? X squared plus 1 was always positive already, and when you square it, still positive. So the numerator is what's driving this thing. And when I put -2 in, I get -4 plus 1. That's -3. So it's a negative number divided by a positive number, which is negative. All right, so the function decreases on its way to -1. Then what happens? If I put 0 in, it's +1 divided by the positive denominator, and that's positive. And if you put 2 in, well, that's symmetric, just like the original was. You get -4 plus 1. That's -3 over +1. That's a negative number. So let's see what's happening here. Going towards -1, it decreases and then increases. Right, so this is a relative minimum. Then over here, it increases and then decreases. So this is a relative maximum. Okay, so what are these values? Right, I'm a little short of room. F of -1 is -1 over -1 squared plus 1. That's -1/2. And F of +1 is 1 over 1 squared plus 1, which is +1/2. So let me put those on my graph. I'm going to go -1, -1/2, 1, +1/2. This is, like I said, it's going to be a very tight graph. It has that -1, -1/2 is a minimum. So we have to start at the asymptote, drop to that point, and then turn around. Increase through the origin, come up to the maximum, turn around, and head back down. And there's my graph. Right, kind of an interesting rational function, right? I think. Okay. So now what? Again, we've kind of been reviewing, right, and just kind of fine-tuning graphs that we already knew how to do. Now in the next lecture, we're going to bring logarithms, exponential functions, trig functions into this, and we're going to do some things where we really, where the calculus is really going to help to figure out what's going on with the function.